Good morning. আজি আমাৰ IndoML second days. আজি আমি ওলালো জাস্ট হোষ্টেলৰ পৰা towards auditorium. যেটো আমাৰ program 9টাৰ পৰা আৰম্ভ হ'ব আজি. And এতিয়া গৈ ব্ৰেকফাষ্টটো কৰিম. তাৰ পিছত proceed to auditorium. যাও লাহে ধীৰে আৰু. This is the Pilani Hyderabad Campus. Last year জানে IndoML beats Goa campus হৈছিলে ইউআৰ হায়দৰাবাদত নেক্সট ইয়াৰ বা ক'ত বা হয় গম নাপাওঁ আৰু এইটো এনাউন্সমেণ্ট পৰহিলে হ'ব চাগে গম নাপাওঁ কি হয় নহয় লাভ BPIC Pilani Hyderabad Campus. আমি সিধা মাৰিছো হেল্ল এতেও ঠাণ্ডা নাই এতে স্পটিং মিন্দি থাকবা পাৰি আমি এটা ডি ব্লক এৰি সোমাই দিম সিধা দে কিবা খালি ডি ব্লক এটো ডি ব্লক 24 তাৰিখে আইবি ওকে হে গকুল বাইরে থাক মামি যাব লাগে মামি এগো আমি সিধাই যাব লাগিব সিধা এই গৈ গৈ তাতে ক্যান্টিন আছে ক্যান্টিন তাপা রাইট টার্ন ল'ব লাগিব আৰু তাতে অডিটোৰিয়াম আছে তাতে আমাৰ আজি তাতে গৈ আজি ফাৰ্ষ্ট সাইন কৰিব লাগিব সাইন হ'লে আৰু পিছলৈ বাকি ষ্টেপ কৰিম আৰু মই গলে মই নেক্সট টাইম নাযাও আজি যে তোমাৰ গালা দিন আছে কিন্তু বহুত এপিনে আই থিংক হ'ব নাজানো এক্স্যাক্টলি নাই গুটেকেটা ৰুমত এই অডিটোৰিয়াম মই পিন যাও মনত পৰে এবাৰ কি কৰবা এই অডিটোৰিয়াম ৰাতিপুৱা ব্ৰেকফাষ্টটো দিব তাতে হা ইয়া সবে লাইনত ৰখি আছে সাইন কৰিবৰ কাৰণে আমি ৰখিব লাগিব আই থিংক এইটো সাইন কৰিব লাগিব এটেনডেন্সৰ তাতে ভাল লাগিছিল ফিলটো নহয় মানে তোমাৰ এনভায়ৰনমেন্ট ও গ্ৰেজুৱেট ফৰ্ম ক'ত আছিল হোটেল যে নালাগে তোমাৰ লাইন বেলেগ কাইন্ড দিছে আমাৰ ইয়াতে হ'ব আজি অকমান সিস্টেমটো বেলেগ গম পাইছা না আজি সিস্টেমটো অকমান বেলেগ মৰ্নিং আফটাৰনুন এণ্ড ইভিনিং গম পাইছা কাহিনী দিটো আমাৰ ব্ৰেকফাষ্ট হৈ গ'ল এটা ধুনীয়াকৈ অডিটোৰিয়াম যাম এইবিলাক পোষ্টাৰ আছে যোৱা কৰিলে অডিটোৰিয়ামত বহি দিম আৰু ফাইনেলি আমি অডিটোৰিয়াম পালোঁ এতিয়া যাওঁ ভিতৰলৈ এতিয়া চিট বা কোন পিনে খালী পাওঁ আমাৰ আৰু দিয়া আমি বহি গ'লোঁ চিটত দহ পুৰা মানুহ একদম চাওক আৰু ইয়াতে Wi-Fi details দিছে
our day 2 session 1 really excited to see you here this morning the Wi-Fi details again if you're missing them are here for your reference so please make a note of it and log into Wi-Fi if you're not so to start Professor Monojit Chaudhary from MBG UAI Professor of Natural Language Processing and his current areas of interest are around convergence of language, technology and society. And in this session, we have two amazing talks. So without further ado, let me introduce our first speaker. So our first speaker is Mrinmay Sachan. Mrinmay is an assistant professor of computer science at ETH Zurich. His research is in the areas of NLP, machine learning, especially applications in education. Prior to this, Mrinmay was a research assistant for the organizers for putting together this wonderful event. It's indeed a privilege to be here. So I want to talk about something that maybe is a little bit different from what we've been used to. I want to talk about AI and education in particular in this
in this era of AI. So let's get started. So over the last few years, we've witnessed this tremendous progress of AI, of course, with large language models. And we keep on hearing how these models have learned to code and to blog and to argue, how AI is mastering language, how AI is being used to make life-changing decisions, for example, in legal context, right? Clearly, these models are everywhere. And one of the most exciting things about these models for me is that these models have really emerged as general-purpose problem solvers, right? For instance, this is the plot taken from the GPT-4 paper, and in this plot, we're already seeing the really almost superhuman, but actually terrific performance of these models on a number of standardized tests, right? And this ranges from the bar exams to the chemistry exams. To
This is the first stop of this today's session. This is the second day.
And so on and so forth. And this is work. So in order to collect this tutoring data, the teachers choose from a number of teaching strategies. So we have these strategies in green, which are called these scaffolding strategies, which focus the attention of a learner to a certain aspect of the problem, or might probe them for their knowledge, or about 3,000 teacher-student dialogues for these math problems. And then we try to fine-tune a number of language models on this task. So this is a typical you can think about this as this is not necessarily a sequence-to-sequence model, but essentially a language model that takes in all of this dialogue history and generates the next tutor's utterance. We augment this architecture with a number of components for predicting the teacher strategy as well as student error prediction. In particular, what the student error predictor is doing is kind of like localizing the particular. This is way back a couple of years ago, and then we fine-tuned a number of open source language models using this approach, using this collected tutoring data. And here I'm showing expert human evaluation on these dialogue tutors on three aspects of goodness of dialogue tutoring. So the three criteria I'm evaluating is sort of coherence, how coherent is the tutor's response with respect to the conversation so far, correctness of their feedback, how correct is the tutor's feedback, as well as this aspect in the learning sciences, which is called equitable tutoring, which is by the LLM judge. So in this plot here, you can see some homework solvers. So we have models like DeepSeek, which are very good at problem solving. Then we can see here a number of baselines, so GPT-4o, and then we have other multi-turn RL approaches or SFT variants for our model. And then we can see here also LearnLM, which is a very powerful Socratic tutoring model from Google, essentially. And we show here how our models for different values of this lambda, which is this trade-off parameter for trading off problem-solving success with pedagogical rewards, and we show it. So next, I'm going to move away from this challenge of pedagogical alignment of large language models, and I'm going to start talking about how do we really generate personalized instructions for the learner? How do we really look at sort of the student model information in a traditional ITS, and how can we use that to generate personalized feedback? So the inspiration for personalized instruction and personalized education comes from the fact that if you think about good educational instructors, and you might be familiar with how Duolingo kind of gives us a continuous way of estimating learner skills. In this case, sort of you have this skill map, which shows you essentially how good you are at a different set of skills. You can use each of so Duolingo uses essentially the skill estimate to give you an opportunity to practice your weaker skills. So in this case, the learner is kind of practicing gerund verbs because they're weaker at that. And a typical example of adaptive learning are these adaptive translation exercises that you often go, right? So for example, in these exercises, you're asked to translate a sentence in the language that you are learning into a language, into L1 language, essentially the language that we're using as a fulcrum to learn this new language. So, however, one of the challenges that Duolingo faces is that Duolingo is constrained to recommending some set of exercises from a fixed pool, right? They don't have a generative model in their backend, which kind of generates these personalized exercises on the fly. So in order to tackle this problem, we propose essentially a solution where we combine knowledge tracing, which is a classic time series model.
Next lecture. Ini kan nama kalau udah dijawab, kembali na, mau nama kalau dijawab.
All right. So, thank you all for coming, and thanks to the IndoML organizers for the invitation and the fantastic organization. I've had a wonderful conversation so far, and I'm looking forward to many more. So, this is from the movie Matrix, and this scene happens right after Neo has just learned Kung Fu, right? And when I'm talking about agent learning, I don't mean like those agent Smiths from this movie, okay? I actually mean the agents like Dr. Mercy Ranjit gave a tutorial on yesterday. And I want you all to free your mind like Neo did in the movie. And I claim that we want to make our AI agents learn. To Professor Brinmai, like I'm not talking about simulating students. I think Suhan Roy asked a question about, students accumulate knowledge, but our LLMs right now don't do it. I'm like, no, free your mind. Imagine if they could. So that I claim is the next research frontier for machine learning. So, my wife complains that I'm spending way too much time on Reddit. But even though I have wasted so much time on Reddit, I have read an infinitesimal fraction of the text that these AI models have been trained on. Is it better now? Yeah. So these AI models are trained on humongous data sets and then they are deployed, but they don't learn on the job. In this talk, I want to claim that these AI agents can learn and improve themselves from rich feedback. So I'm going to make it concrete with an example. Maybe you have also faced this. So I do not like JavaScript. I don't like programming in JavaScript. So to do that, I usually use these coding agents like Claude Code or something. So I'll just prompt it, it'll generate some JavaScript code, and then I'll review it and I'll fix mistakes. Okay? Now this is a very explicit, rich feedback in the form of a code correction, but the agent doesn't learn from that. I go to a new repository, I try to make some other JavaScript code, and it still makes the kinds of mistakes that I just corrected. So I find that I'm having to learn from its mistakes and then prompt it differently, or I go and edit the Claude Markdown files. So bloody hell, I'm having to learn on its behalf. The spirit of agent learning is to take the feedback that we are naturally producing and turn them into learning signals so that these agents can get better over time. So why haven't we solved agent learning yet? Well, because agents are complicated, and in fact, they're going to remain complicated. And this is research that we presented at NeurIPS just a couple of weeks ago, where we showed that LLMs have fundamental limits on some complex tasks. So just scaling up the LLM bigger and bigger is not going to simplify agents. Agents will have to be a composite of LLMs and tools and RAG and things like that. It's not just an accident of the current times we are in. So let's dive deeper into these LLM limits. Okay? And to do that, I want you to think of the flow of information inside a transformer. So here along the x-axis, I have laid out the input tokens in the context of a transformer. And along the y-axis, I have just stacked up the different layers of the transformer. And a token at position n, using self-attention, can attend to all the preceding tokens. This is the causal attention mask in transformers. Though I find it very annoying that they use the word causal. Now, let's just draw an imaginary line and split the input tokens into a prefix and a suffix. Think about all the computation that's happening here in this prefix, right? Because of the causal attention mask, none of this computation can look at any of the suffix tokens. So, if there is some information in the prefix that is necessary to compute the correct answer at this eventual output token, it has to come in through one of two ways, right? Like either the self-attention mechanism has to pull in that information from the prefix, or the prefix computation must calculate something like SK2 out here without ever looking at the suffix tokens. And that kind of a communication pattern we can just abstract out into a two-player communication game. So there is a prefix oracle
that gets access to all the prefix tokens, and it's going to produce some output which is bounded, right? And then variable C is, and so on, right? Like, so you just have this entire pseudo code, and you're prompting the LLM to say, like, here are the variables you're allowed to change. Debug through this entire pseudo code, and see, this is the feedback I got. Tell me what the new values of these variables should be, right? Turns out, a whole bunch of problems in the literature can be viewed through this lens. Prompt optimization, code optimization, jointly doing both, hyperparameter tuning, numerical optimization, everything basically fits into the same pattern. So we are able to run the exact same Optoprime optimizer without a single change to its prompts or anything on all these different problems. On that battleship example, you know, if you just initialized with some code, you know, it's basically not even working, right? The environment is just choking on the initial output. After one round of iteration of feedback, it's basically analogous to, you know, if you prompted GPT to give you the code for Battleship, given this initialization, you would get some output that looks like this, which is essentially an enumeration strategy that it's following. But if you allow it to interact with the environment a couple of times and get that feedback completely autonomously, it's come up with this far more sophisticated code, which is actually a pretty interesting way to balance exploration and exploitation. And I already mentioned that trace has been used to optimize hyperparameters and prompts and code. I'll just highlight very briefly this. So this was, when I say jailbreaking an LLM, we haven't been the ones doing all of this. There are students from Stanford and CMU and in France, in I think ETH Zurich, I believe. No, not ETH, EPFL, sorry. No, that's also Switzerland. Okay, I'm blanking on the students' university affiliation. It's in France. So they have been applying trace for all kinds of fascinating problems. The student at UW who tried this for jailbreaking basically told me that the current state of the art for jailbreaking is, you know, students manually try many different strategies, and then they find one that works, they publish a paper about it. And using trace, he was able to operate at a meta level. You know, he could just tell the optimizer, like, you know, here are the kinds of strategies that people have used. Now go and automatically optimize and find me like new jailbreaking prompts on your own. And trace just does it. Like, it just figures out very interesting ways of like composing known attack vectors and things like that. And just like what was earlier a sort of manual one paper at a time thing, now it's like a much more automatic jailbreaking study. So with that, I just wanted to say that we are at an exciting frontier of learning. I want to make these machines learn like we humans do from rich feedback. And the parameters, both classic and agentic, can be tuned using tools like OLAF and Trace. Now, in the final part of the talk, perfect timing, let me just step back and philosophize for a couple of minutes. So I'm also a fan of history, and looking at the history of our field in AI, I have felt like better optimization and learning algorithms have unlocked advances in newer models and more complex things, and just a fundamentally better capability of AI. So I just found out yesterday Bernie Woodrow passed away. Bernie was the one who created Adeline, one of the first artificial neurons. Right? Rosenblatt at Cornell did the first perceptron, but Adeline was from Stanford by Bernie and his collaborators. But preceding the Adeline work was the optimization algorithm. Of course, back then they did not call it SGD, they called it LMS algorithm. But if I said LMS, I don't think any of you would get it. So I don't think any of the students here would get it. I think the professors would all know. But you can go back and read those papers from the 50s and see like the ideas of SGD were invented back then, and that then led to the model Adeline. Then, backprop in the 80s allowed us to scale up those neural networks to be like multi-layer and allow us to do things like convolutional neural networks. And, that unlocked a whole bunch of new capability. Then things like Adam and automatic differentiation, PyTorch and so on, allowed us to go to things like transformers. Till date, if you ask me to by hand write down the gradient value of the self-attention mechanism in transformer, I think I'll tear out my hair in frustration, right? I cannot imagine doing it if not for automatic differentiation. And trust me, from 2010 to 14, I have written many different variants by hand and coded it up. Then we had techniques like TPO that allowed us to scale to billions of parameters neural networks. And really what I'm saying is, there must be new kinds of optimization techniques that can scale to all these rich parameter spaces. And maybe that's going to unlock all kinds of new agent architectures, that we can't even imagine of right now if we had to tune it all manually, right? Like we must need some kind of automatic technique to unlock that next model breakthrough. And maybe I'm hopeful that gets us a step closer to human level AI. But I guess looking at history always, I also think about my personal history, and here's a snippet from the acknowledgement section of my dissertation. And I'm especially missing my gurus right now because I was shocked by the passing of IITB professors Divan and Professor Pushpak this year. And I just wanted to highlight one thing that I imbibed from them, which is don't cut corners, learn to discern, right? Like, so figure out how you can distinguish between really great work and substandard work. And this was very apparent to me when I was a TA. Like I saw some students who viewed their learning as an investment and some who viewed it as a tax. And they really wanted to cut corners to lower their tax. Right? And it was important to discern. So why am I talking about discernment, right? Like when I think of these agents that are learning, well, where are they getting their rich feedback from? And I 100% agree with Professor Mrinmay, right? Except I've sort of inverted his talk, right? Here, it's not an intelligent tutoring system that's teaching human students. We will have to be the ones that are teaching these learning agents, right? And so
if you had a good session at mentorship and also a good tea break, and I hope the others missing here will also keep coming in as the session starts. And I think the session will, I'm quite sure will probably bring the people here, considering the sound effects that you'll probably hear over the talk. And that's probably the preview to the session. The next speaker is Dr. Scalable Systems that work around the world. She's been at IIT Bombay, Penn State University, led large initiatives that led to research in Bangalore. And from what I could see during their testing in the last few minutes or so,
to define media experiences and make them more intelligent, and data, AI and machine learning plays a key role in that. So before I dive in, I wanted to also share a little bit about why I personally care about this problem. And I thought I'll put together a very quick journey on how I got to be where I am. So very fortunate to start my journey at IIT Bombay with foundations in data, machine learning and AI. And I was one of the lucky ones who in 2004 took Professor Pushpak Bhattacharya's AI intelligence course. So that was how it started. Quickly, after finishing my master's, I moved to Yahoo Labs, and I realized that even though the problems may be similar, you may be talking about object detection, tagging, contextual search, it's a very different beast when you think about global scale. And so definitely data set and AI infrastructure scaling became core themes of what I was doing. I realized there's one very crucial thing, that yes, algorithms matter, yes, systems matter, but what are experiences, how we train these models on the cloud, and then optimize them for edge devices. So cloud to edge efficiency and AI acceleration is a theme that you will commonly hear when you talk to my group in Bangalore. Okay, so the way I've organized, I'm going to be a guide, I'm going to take you on a journey which tells us how media has evolved from broadcast to intelligent experiences. I'll start with a brief introduction to Dolby and then talk about some of the research areas that involve data, AI, and machine learning. And then there's a pitch about how there's some problems which are not yet defined and where we need strong collaboration across industry and academia to take to the next level. Okay. So I'm going to start with the beginning. Of course, there's a very strong, Dolby has a very interesting connection to India. So Ray Dolby, he's the founder of Dolby. He founded Dolby in 1965. But after finishing his PhD in physics from Cambridge, he actually came to India where he was a technical advisor to UN. And he became very interested in learning about Indian and recording Indian classical music, folk music. And when he played it back, he was irritated by the analog tape recorder noise. And so he started thinking a lot about noise reduction technology. And over the course of, like, after founding Dolby, that's where much of the efforts went in. Dolby now has, of course, scaled significantly. We are 2,300 people worldwide. And these are distributed in 20 countries and over 30 cities. So you will see on this graph there are some purple dots which indicate where the research happens. So we are headquartered in San Francisco, but the Bangalore site is something that's coming up rapidly, and I'll talk a little bit about that. So the Advanced Technology Group in Bangalore is a new R&D growth hub. And the first employee started in 2023. I myself started last year, and we are now 25 PhD researchers who are essentially looking at media AI. There are 3 or 4 key areas where we focus on. So areas on video processing in 3D, multimodal and foundational AI. And my group focuses on experience delivery, building the data platform in AI services. We recruit from the top universities in and outside of India, as many of them are here, and you'll meet them in our booth if you stop by. Okay, so very quickly, what type of experiences? So you probably have seen this slide before, but our purpose is to unlock the power of sight and sound in the pursuit of awe-inspiring experiences that transform how we connect with each other and the world around. We have 3 products that are like most commonly known. So Dolby Atmos, Dolby Vision, and Cinema. So Dolby Atmos is a suite of spatial audio rendering technologies, and it treats sound not as discrete speaker feeds, but it actually treats them as audio objects which has spatial metadata. And so depending on where you play, your TV could render audio in 2 channels, your home theater could be 16 channels, and in immersive theaters it could be 128 channel cinema. So you can experience that in an immersive fashion. Dolby Vision is the high dynamic range. So it offers much wider range of light and color than the standard methods. And that makes bright highlights brighter and dark shadows deeper and colors more vivid compared to the standard dynamic range. And these technologies come together in Dolby Cinema. So even though there are 3 technologies, actually these being content creators, distributors, and experience deliverers. So which is like endpoints, so countless devices. So we work with studios such as Netflix, Lionsgate, HBO to create content, encode it, post-produce, and then stream them. And then in terms of endpoints, there's just like you won't even realize, but Dolby, you have your phone, your earbud, your smart glasses, your cars, so they're all on either already on Dolby technology or on the way there. A little bit of promotional slide in the sense that Dolby has been very widely used in creating content across myriads of categories and genres of TV, movies, sports, games, music, and podcast. And it's also very widely, it's beloved, and some of the most popular award-winning content is produced in Dolby Vision and or Dolby Atmos. Okay, so now we start to get into the technology part. So what do we do? So I think Dolby has amassed a large number of patents, over 12,000 patents, and 15 Emmys. Some of these are technical Emmys, so our VPs and our directors who work on site in sound experiences, they themselves are a recipient of bringing new type of technology to this field. And in that process, we also have started publishing more significantly, more so in the recent years. So there are over 100 papers published in top venues in this by this Advanced Technology Group, which is worldwide is 250, and now we are 25 in Bangalore. Some of the top conferences and journals across all areas of data, AI, and ML. Okay. So that was my brief introduction to what Dolby do. Hopefully I've done a little bit of some job to tell us that it's not just sound, but we have more breadth. And now I'm going to talk about some of the research areas where we focus our efforts. So internally, Dolby Advanced Technology Group is organized as 4 labs. So sound experiences and sight experiences, those are more established. They have more decades in them. So they focus on audio capture and rendering, coding, and now deep learning for audio applications. Similarly, on the sight experiences side, there's a lot of work on video compression, restoration, enhancement, 3D and volumetric experiences. Multimodal Experiences Lab focuses on human and machine perception and reasoning, psychophysics, elements of multimodal representation, processing, and generative AI. And Experience Relay Lab, this is just 2 years old, that focuses on building a data platform, AI infrastructure, where we can start training these models. So traditionally, we have a lot of, there was a talk yesterday about, data and AI platforms, but those necessarily don't work for audiovisual content and immersive content, where you have a lot of different elements than the traditional types of data sets, structured data sets. So we are trying to develop, make some innovations there, both on the server side and also deploying and compressing and optimizing those models for edge. We are also interested in a lot of media delivery formats. So in the next 5 minutes or so, what I've done is I've taken sample research problems from all these 4 labs to show you the breadth. So let's look at sound. The top row will show some of the areas we work in, but here I'm only focusing on deep learning for audio applications. Source separation is something that we've been doing for many years now. So here we are now bringing deep learning for source separation, which takes a mixture of sound and you put it through a network, and you can separate dialogue, music, effects. We're also looking at how, if you have other additional modalities available, for example, if you have, the second example shows, that if you have an image and if you kind of do object detection, classification, then the joint analysis also gives powerful insight into source separation and enhancement. And then finally, generative audio is also very hot and upcoming area for content creation, gaming, and XR. So this is one area. I know some of you have been asking us for sound research, and we're happy to discuss any potential collaborations in this space. Okay, the next example is from our site experiences. So Dolby has a lot of work traditionally on, of course, the HDR vision, image capture research, video processing, and restoration, and so on. It does also a lot of work in codecs and compression. And this particular work, it talks about ultra low bitrate generative codec. GFVC, this is actually one of our recent work. This is done by a researcher in Bangalore. It's been accepted into standard. We do publish a lot of work into MPEG standards and codecs. And this was also, it also won the best industry paper award at ISIP 2025. So we're very proud of this work. There's work around volumetric processing. We have good talent that is looking into 3D scene representation, volumetric capture, head-mounted displays, NERF, Gaussian splats, multi-view image rendering, and those areas. That's not my area, but we have an expert at our booth. So if you want to learn more, please join us. Okay. Multimodal area. I think multimodality, there's a lot of promise. There's a lot of different type of data sets that we could collect, and that will give rise to different types of problem statements. So the one area is on human-computer interfaces and human sensing. So we do research in capturing user behavior using camera and microphones, and that helps you to quantify gestures, pose, quantify user emotion and engagement. And of course, once you have that, you can think about creating closed-loop interactive and personalized experiences. These would have to be run on edge devices or have in some sort of federated setting if you have privacy concerns. We can take this learning and then go to the second area, which is the multimodal neuroscience and perception. So we have a team that looks into neuroscience areas, and physiological signals to perform subjective assessment of user consuming multimodal content. There's a lot of analysis of EEG recording and analysis of auditory and visual perceptual studies. So what this particular example shows is that once you're fitted, in this particular experiment, they were trying to understand how Dolby Vision affects users. So water looks wet and fire looks warm. So in this case, what they noticed is that when the users are looking into Dolby Vision, a fire scene, the face actually gets warmer, right? So those are like very interesting signals for us. Of course, because this is a subjective study, we can't really scale it, but we are actually looking into areas by which we can train machine learning models to come up with objective assessment or approximation to subjective evaluation. And these are the type of models that we put into wearables and physiological sensing. So there is some work into measuring and analyzing physiological data for entertainment experiences at the edge. Okay, also a lot of work in the standard multimodal analysis, enhancement, generative AI, and representation. So here we're trying to also this can also be useful for creating professional tools. For example, there was if you're shooting a movie, heading next. So the shift towards intelligent media features. So I put together a slide which shows how media itself has evolved from broadcast to future. So some of you, I don't know, many students may not remember or were not there probably at this time, but I remember pre-90s, around 87, 88, Ramayana was a big phenomenon across all of India. It's people at, I think, 9 or 10 a.m. in the morning. Everybody would drop everything that they had and they would be glued to front of television. Because if they miss that time slot, they're not gonna see it again. So in the pre-broadcast era, your experience was defined by the broadcaster. It was same content that was broadcast everywhere. It was fixed schedule and no rewind, no personalization. Afterwards, as content, audio, video became more digital, we had more content. It's going to be interactive, it's going to be non-linear, captured from multiple views and experience through multiple devices, a plurality of devices. You might have your video or smart glasses, you have something, even people who are traveling in car, right? There are 4 people, 4 passengers. So you may, right now, everybody experiences the same experience, creation and agents, where a focus could be building intelligent, interactive experiences. And I put in a sample problem, so it could be around generating rich multimodal scenes for AR, VR, film, or sports. We could also design agentic characters that observe, reason, and act in immersive narratives. Another track for collaboration could be on semantic, affective, or cultural adaptation, because entertainment is produced everywhere, but they may not resonate similarly to global audiences. So adapting media and entertainment content, like movies or music, to the needs of regional audiences, and using that through linguistic, cultural, or emotional resonance could be a very big area. So here the sample problems could be on cross-lingual speech synthesis, dubbing, lip sync with emotion-preserving voices, audio-video content restoration, enhancement. I would love, like, if my kid can enjoy shows like Ramayana or Bharat Ek Khoj the same way, the same impact it had on me. But of course, not one man. So it needs some kind of adaptation of old content to new content. Also, like bringing some of the Western media to Indian content. It could be a very interesting problem, and I think it could be a problem that is very appealing to this IndoML community. So we could also look into this kind of culture-aware editing, policy-preserving editing, at the same time looking at protecting the original signature or rights of the content creator. We have some people here who are looking at mechanistic interpretability, for example. So that also is an area that could be relevant. Third track is on real-time distribution and edge adaptation. I think I've said it enough. But scaling entertainment AI on consumer devices and networks. So there are a lot of sample problems on low latency inference for audio video enhancement, adaptive playback, multi-device synchronization, and RL. So, and finally, like the 4th track is on core foundations for spatial understanding, media and entertainment. So here we are looking into multimodal reasoning, cross-modal embeddings. There's a lot of work happening in the group on graph-based scene representation, so scene graph, temporal scene graph, There's some active collaborations, and also on scaling these algorithms through distributed training, lineage, and evaluation. So I've talked about these sample problems, and now I'll talk about what are the ways you can get involved. So there are 3 ways. The first one is the Greenfield PhD internship program. It's very popular in the US. We've started to institute that in India. So here we want PhD candidates to come and spend 3 months with us on a problem of, in one of these focus areas, but the problem of their choice. And it can usually lead to a publication and also be part of their thesis. So it's very popular. And in the process, we learn something in return. The second area is faculty research collaborations. So Dolby has an annual call for proposal where interested faculty can submit a brief research proposal, and we have Dolby researchers and faculty collaborating on that. And usually, like a paper, like it's given as a big funding, but it's a very healthy collaboration where, again, I think the purpose is to develop the state of the art and future of media experiences. We have 5 strategic partners in the US, University of Massachusetts Amherst, UMB, USC, Georgia Tech, and Northwestern. We've launched this program in India this year, and we've started some collaboration with IIT Bombay, IIT Kanpur, and IIT Madras. So the next round of proposal, call for proposal is due in March. So if you're interested, we would love to partner with you and collaborate with you and help shape the proposal. And then the third piece that we work on is industry academia events. So these are kind of mini summits, like 30-40 people. It usually happens in headquarters. We would love to start something in India, where we bring together industry and academia leaders to talk about specific topics and initiate new collaboration. So some of the recent examples, in the last 3 years, there was a Future of Cinema Summit, Future of Learning Summit, and Smart Realities, which focuses on more of smart glasses and XR. So if you're interested to know more, please visit our booth. We are happy to chat with you. We are here tomorrow as well, and you can always reach us offline through many other people. So with that, I come to the conclusion side. I have a video to play right after this, but we want you to play, build the future of entertainment together. So maybe it's a 2-minute video, if I have time. Okay. Let me see. Okay, like this.
Have something inside of you, you hear it and you feel it in a certain way. So to be able to have the tools with which to actually fully realize it the way you envision it inside, that's heaven for an artist.
We wanted the tools that would indicate that epicness, and Dolby lent it that power. It's like a whole new experience.
When I first saw the Atmos on the console, I was very excited because it's something that I've always thought would be
a game. We want to give our audiences the next best option. It really will feel like you're at the game. It gives a completely different experience.
You know, you got the best qualities, you can feel it to the fullest extent. You don't just...
Dolby technologies offer opportunities and inspiration for stories that couldn't have been told before.
It's as if we've been saying, really transported me to that atmosphere, to that place.
I remember we first got into a suite and started grading. We just couldn't believe the results. The image becomes...
You hear everything, and you can hear everything in different spaces.
So for you to be able to experience it that way elevates the story and where I want to put the viewer. And without that technology, you just don't have the same experience.
Thank you. That's the end of my presentation. We are a team of 5. Sorry, this one. Just quickly stop. I don't know if I have time for question answers. I can also take them later. No worries.
So you can see that the infant is trying to cry, but not able to make proper voicing of the glottal vocal folds because the laryngeal part is not properly developed. So the objective of this talk is actually to develop algorithms, machine-based algorithms, which can analyze, first basically The difference between this normal, because normal could be the pain, muscle pain, hunger cry, among others, and you can say atypical, that is pathological, it can be, let's say, the asthmatic cry, the laryngomalacia, the lack of supply of oxygen to the brain, HIE, and like asphyxia. So this is the objective of the work. And this field is highly interdisciplinary, infant cry analysis, classification, and as an extension to is a language acquisition. It depends upon pediatric knowledge derived from pediatrics, neurology, physiology, engineering, developmental linguistics, that is language acquisition, and psychology. Of course, the objective, you can say the motivation from the societal viewpoint is to develop a mobile app where the cry segments can be sent over the cloud network, and there is a software which can compare and give some kind of score to see that how much it is normal or pathological. In fact, there is one such app developed in abroad called Ubenwa app in the mobile. As an international platform for the research, this area is very important with respect to seeds. Many states, the National Institute of Health, which supported the study, and that study found those infants suffering from the seeds, that seeds means infants die without any region suddenly within 3 months of birth. There is an abnormality in the medulla oblongata of the brain, which is known to control the breathing functions. Similarly, there are studies showing lower fundamental or pitch frequencies, longer duration of the cry unit, greater sound pressure level for those infants suffering from the seeds, and even those infants have first cry having higher first formant frequency. And one of the path-breaking studies by Harrison, whose team removed the 74 lakh. This corpus, there are a lot of developing such corpus. There are ethical issues, getting permissions from the hospitals and authorities, and also the consent from the parents. And also, how do we give the stimulus, to the infant, which is so very sensitive, basically. So, with this, we collected our corpus. The student has collected as a summary research internship, and these are the details. And then I would also like to inform there is a one corpus available with license agreement that is called baby children corpus, and there is a having the other pathology than our corpus containing asphyxia and death as a pathology compared to the normal cry that they have. And this you can use it for research. This is one snapshot of the analysis of infant cry using the well-known short-time Fourier transform versus linear prediction spectrum. So you can see that the black-colored spectrum is an LP spectrum. The red color one is basically the STFT Fourier spectrum. So as we increase the LP order, we found that the resonant frequency of the infant focal tract now misidentified as a pitch frequencies here. So this analysis is not sufficient. We need to do something better in terms of algorithm development. This was the objective from this plot. Then we went to basically analyze using the short time Fourier transform, which is nothing but the Fourier transform for a short segment of the speech wave. And you can see here that the pitch period or the pitch frequency, you can say that from male to female to children to infant, the pitch period decreases, hence the pitch period frequency actually increases, because the mass of the vocal folds on children, or you can say the female, is much lesser than the males, so they take more time, the males will take more time to complete a glottal cycle, so therefore they will have lesser pitch frequency than the females, and so is the case for the children and the infant. So, in one of the signal processing challenge of processing infant cry,
या ब्रह्माच्युतशङ्कर प्रभृतिभिर्देवै सदा वन्दिता सा मां पातु सरस्वती भगवती
reverb a little bit. So thank you to
Hello, check. Hello, hello, check. Thank you to the Computer Science Department for giving us this opportunity to perform on the stage. So we have decided to perform a classical, Hindustani classical music today, starting with Rag Yaman. So Rag Yaman is a Hindustani classical music raga, which has a beautiful, serene, romantic mood. It creates peace, calmness, and happiness, and a sense of joyful devotion. So Rag Yaman is frequently used in a lot of popular Hindi music, like in Bollywood music, in bhajans, in thumris, and ghazals. So I will be presenting a small composition on Rag Yaman, which is called Kinare Kinare Dariya Kashto Badhu मौजाए बहरे उल्फत में फिजार खेवन हार की लाज तुम्ही को दाता खरी हो दुआरे 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 दरिया कश्ती बांधो. So this bandis is on 16 beats. Let me show you the tal he will be playing. Dha dhin tha dha dhin tha na tin ta ta dhin tha. किनारे 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 दरिया कष्ट बांधो किनारे 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 दरिया कष्ट बांधो किनारे 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 दरिया कष्ट बांधो मौजाए बहरे उल्फत बेखिज़र मौजाए बहरे उल्फत बेखिज़र किनारे 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 दरिया कष्ट बांधो किनारे किनारे हे बलहार की दाता तुम्ही हो हे बलहार की हे बलहार की लाज तुम्ही को हे बलहार की लाज तुम्ही को.
Galadina location. Galadina locations. Just started.